Let's look at the R alpha method through a few examples. Example 1, express 5 sine x plus 12 cos x in the form r sine x plus alpha, where r is greater than 0 and alpha is between 0 and 90 degrees. Now, for these types of questions, we want to use the addition formulas that are given to us in our formula book. In particular, we want to use the sine one this time because the format that they want involves sine x plus alpha. So the first step for part A is to write out r sine x plus alpha using the addition formula. So that's going to be r and then sine x cos alpha plus cos x sine alpha. Multiply through by r and you get this. This stage, we now look at doing spot the difference. And by that I mean in the original expression, they have a 5 sine x, but in our new expression, we have r cos alpha sine x. And that means then that r cos alpha is 5. Similarly, in the original expression, they had 12 cos x, and we've got r sine alpha cos x. So that means r sine alpha is 12. Now there's a shortcut here to find r. You can say that r is literally just the square root of 12 squared plus 5 squared. So the square root of those two values squared, which in this case equals 13. For completeness, I will show you where this shortcut comes from, but you don't have to write this down in the exam. It comes from this. So if we were to square the two values we found earlier and add them together, that would be 12 squared plus 5 squared. We can factor out an r squared, and if we do that, you can see we get sine squared alpha plus cos squared alpha in the bracket, which according to the identity is just 1, so cancels out. Therefore, we're left with r squared is 12 squared plus 5 squared, and therefore r is the square root of that. Back to the main working, which you would write down in the exam. In order to find alpha, the shortcut is to say that tan alpha is in fact 12 over 5. Again, I'm going to show you where we get that from. That's literally just from dividing r sine alpha by r cos alpha. The r's cancel out, and then sine alpha over cos alpha is tan alpha. Easy. Here you can find alpha, just doing inverse tan. Watch out for degrees or radians as always. And in this case, we're in degrees, 67.3801. So around 67.4. Altogether then, we can express 5 sine x plus 12 cos x as 13 sine x plus 67.4. And that's it. Look at part B now. Hence find the maximum value of 5 sine x plus 12 cos x and find the smallest positive value of x for which this maximum occurs. So we now know from part A that 5 sine x plus 12 cos x can be written as 13 sine x plus 67.4. Now, if we want to know the maximum value of this expression, all we need to do is consider what is the maximum that sine can ever be as a function. And we all know that the maximum sine can ever be is positive 1. Doesn't matter what x is, the maximum of that particular part of the function is always 1. That makes this really easy then, because then we just say that the maximum value of the expression or function altogether is just 13 times 1, which is just 13. As you can imagine, it would be pretty similar if they asked for the minimum value, but you would use minus 1 instead of plus 1. When does this maximum value occur? Well, it occurs when sine x plus 67.4 is equal to 1. Let's work this out then. So x plus 67.4 would be the inverse sine of 1, which is 90. That's the smallest positive value anyway. And then take away 67.4 to get x, 22.6. And that still works as the final answer because that is a positive value of x. If we were to get a negative value of x at the end, we need to look for the next solution after 90. Example 2, here we have another function and we want to express it as r cos theta minus alpha. We want the value of r and the value of alpha. This time we're in radians. I know that because I'm looking here and I see pi. So let's start by looking at the addition formula for cos this time and using that to write down r cos theta minus alpha. Let's expand that out. So that would be r and then cos theta cos alpha plus sine theta sine alpha. Multiply through by r. Now we play spot the difference. They've got 5. We've got r cos alpha. So r cos alpha is 5. They've got a 1, invisible 1. We've got r sine alpha, means r sine alpha is 1. Let's do our new trick or shortcut. R is the square root of those two numbers squared in either order. So r is root 26. Then tan alpha is sine alpha over cos alpha. So order matters here, 1 over 5. Alpha inverse tan of that in radians, 0.197 to 3 dp. Part A done. For part B, they want us to solve that equation equal to 2. Now the word hence usually gives it away, but we are going to use our answer from part A for this. So we need to know that r was root 26 and alpha is 0.197. So the equation in part B is 5 cos theta plus sine theta is 2. Can't really solve that as it is because we've got a mix of cos theta and sine theta. So if we use the format from part A instead, that would be root 26 cos theta minus 0.197 equals 2. Now that is definitely solvable. So let's go ahead and do that. Divide through by root 26, inverse cos. We want theta to be between 0 and 2 pi. So that means we want theta minus 0.197 to be between minus 0.197 and 2 pi minus 0.197, which is 6.086. The first answer that comes out of the calculator is 1.168. That's within range, that's fine. Let's get the other one from doing a sketch. So cos graph like this, 0 up to 2 pi. Line across, we can see two solutions. First one was our 1.168. This is the other one that we want, and that's 2 pi minus 1.168. That works out to be 5.115, again within range, so that's good. All that's left to do is to find the final theta values by adding on 0.197. We get 1.37 rounding and 5.31, and we're done. That's it for now. If you found this video useful, please do remember to like, comment and subscribe to my channel if you haven't already, and do share this with anyone else you think might find it helpful. Thanks, and see you next time.